right, so this was a review of the stuff we did yesterday, where we're finding stuff that are like terms and combining them. So in number one, what are the things that were alike and we could combine them? What were the terms? What can we combine? Yeah, everything with a y in it, right? So there are how many terms? There's 3 of those. And this means -1, and that's -3, and that's -1. So remember yesterday we learned that when we're adding or subtracting, we do not add the exponents, right? We're just doing the coefficients. So if I have -1 here, -3 is -4, -1 is -5. So that's -5y minus 6, right? The 6 doesn't combine with anything, so we just bring it down. And then for number 2, what things combine? 2x and the single x, they combine. What's 2x plus another x? 3 x's. And then -3y and 4 just come along for the ride because they don't combine with anybody. On number 3, this one kind of plays a mind trick on you. Who put 0? Anyone? I did too the first time. But you have to slow down. It's not 0. What is it? -12. When you're looking real fast, you're like, oh, everything just cancels out. But only these 2 things canceled out. And then we get -6 minus 6 is -12. And then the trick with number 4, or not the trick, but the skill that you're supposed to be doing, is everything has an a and a b in it, but you also have to look at which ones have matching exponents. Which of the terms match exactly? 7 and the -9, right? So 7a squared b and -9a squared b makes -2a squared b plus 8ab squared, because that doesn't go with anything. Poor guy or girl. Right? And so then this last one was a geometry concept. The sides of a triangle are 3x plus 2, 6x minus 1, and 7 minus x. Express the perimeter of the triangle. When we're doing perimeter, what are we doing with all 3 sides? Which math operation? We're adding, right? So we take all 3 of those sides, and we add them. So after that, we combine like terms. We combine all the x's. I have 3 here, plus 6 makes 9x, minus 1 here is 8x. And then we combine all the constants, right? The numbers. I have plus 2, minus 1 is positive 1, and then plus that 7 is positive 8. And there's no units in the problem, so we don't have to write anything. But if there was units, you'd want to write those down. Okay, so we got all those right as a review from yesterday. Okay, perfect. What we're doing today is multiplying polynomials. So yesterday we added them. Today we will multiply them. And what I want you to do by yourself first off when you get the worksheet is the first column here. It's more of what we just talked about. So do this here for just a moment by yourself. 7m squared. Yeah, 7m squared n cubed. Very good. Chrislon, what about the second one? 6x squared minus 2x squared is what? Yep, 4x squared. And Hayden, what about that last one? It stays the same. How'd you know that? Because they're not like terms. They both have x's, but the exponents are different, right? So we can't combine them. So it stays just the same. That's perfect. Now here's the point of this table, okay, at the beginning of the lesson. Yesterday we added or subtracted these things. Today we're going to multiply them. So I have the exact same things over here, the same terms, but on this side of the table we're going to multiply them and look at how it gives us different answers, okay? One thing, I kind of am going to work this table backwards. I'm going to start here. I'm going to talk about some things in this bottom problem because I want to review what the power even means. So for example, x cubed, what does that mean? What does that mean? x times x times x, right? And so that's what x cubed means. What does x squared mean? X times x. So in this problem, what we're about to do is multiply x cubed times x squared. Now I'm only going to do this out long one time because we did exponent rules last semester, so we're not going to spend a long time drawing them out really long. But here's what x cubed times x squared means. It means the 3 x's times 2 more x's. Okay, so now how do I write x being multiplied? X to the 5th. What did I do with what's the shortcut? You add the exponents, okay? So what I want you to write here on the top of this table is when you're multiplying with exponents, you do add the exponents. And on the top of the left-hand side, I want you to add, do not add exponents. Okay, that's the takeaway that I wanted you to have. I just was originally going to write it down here, but then I decided to do it on top of the table. So when you're adding or subtracting, you do not add the exponents. When you multiply, you do add the exponents. So finishing out this bottom problem, we know that the x cubed times the x squared is x to the 5th. And then we just have to do the negative 4 times 3. What is negative 4 times 3? Negative 12. Negative 12, right? So try this problem right here. Do that one. 6x squared times negative 2x squared. And raise your hand when you have that one done, please. Thank you. Thank you. Thank you. Amber, what did you get for that one, please? Perfect. Negative 12x to the 4th. And then the top problem, the only reason that one's a little bit different is there's 2 variables, okay? But everything still works the same. It's kind of like you're multiplying 3 different sections. You're multiplying the coefficient, which is 3 times 4, which is 12. And then you're multiplying the m's, m to the 4, right? Because you're adding the exponents. And then you're multiplying the n's. What does that give you? N to the 6th. Okay. Right. So that is how you can take the exact same terms. It looks different when you're multiplying than when you're adding or subtracting. And all we're doing for the rest of the lesson is talking about multiplying polynomials, all right? And by the way, we have a quiz coming up on Tuesday. So down here, we're going to talk, I originally wanted to talk about 3 different methods, but we're just going to skip the 3rd method, okay? It just ends up, in my other classes today, it ended up being just too much information. So we're just going to talk about these 2 methods. The first one is distributive. Distributive is what you get when you have one term, right, a monomial, times a bunch of other terms, okay? In this case, it's a trinomial. And so you're just going to take that negative 2y and multiply it by this term, and this term, and this term. So I want you to try that on your paper and see what you come up with, please. All right, the next problem is a little bit weird, but it's nothing we can't handle, okay? So when I distribute, I'm going to do this times the x squared, all right? So remember, you're going to multiply all the like pieces together. Like, you're going to do the coefficients first. So it's 3 times the 1 that's here. So 3 times 1 is 3. You're going to multiply the x's together. X cubed times the x squared is what? X to the 5th. And then you're going to multiply the y's together. Only what's up with this term? There is no y, right? So it's kind of like there's a y to the 0 there. It's kind of like you can think about it like this. So if I was taking this y times y to the 0 and I was adding the exponents, what would it give me? Just y to the 1, okay? So, or you can also just think about it in less mathematical terms. You're just going to smush the y on the end. Just going to slap it on there, okay? And then we've got the next term, so we're distributing it there. 3 times the negative 8 is negative 24. Multiplying the x's gives you how many? X to the 4. And multiplying the y's gives you how many? Y to the second. And then distributing it to the very last term, 3 times the coefficient over there, which is just 1, so I have plus 3. That last term has no x's, so it's really like x to the 0. So when you're adding the exponents, it'll give you x cubed. And then the y's are y cubed. Okay? So kind of a big, ugly looking problem, but nothing we can't handle. Right? It's not really too bad. So what we just did was distributive property. This next method is called FOIL, which you've seen like for your whole math algebra life, right? But it's also really just a double distributive property. It's kind of like you're just thinking about like cover this up. You're going to distribute that 5 through. And then you're also going to distribute this y through. Okay? So sometimes I like to think of it as just double distributive property. But remember, here's what the letters stand for. It stands for first, outside, inside, last. The first means the first term inside each parenthesis. So the y's. Okay, that's the first. This y is the first one here, and this y is the first one in the second group. So what do you get when you multiply those? Y squared. Done. The O stands for the outside terms. Okay. Y is on the outside left, and 8 is on the outside right. And so what is y times 8? 8y. I stands for the inside terms. Which ones are the inside terms? The 5 and this y right here. So that gives me 5y. And then L stands for the last terms. Which ones are the last ones? 5 and 8. And 5 times 8 is 40. And now that we have all that done, we combine whatever we can combine. What combines here? The 5 and the 8y. So this gives me y squared plus 13y plus 40. Okay. You try number 4. In fact, you can try the rest of them. I just want to give you a heads up about 5 and 6. The thing that's different about 5 is there's 2 variables, but you can handle that. And the thing that's different about 6 is nothing will combine on the last step. Right? So take a few minutes and do FOIL on those last few problems, and then we'll talk about it. All right, let's talk about these. So for number 4, F stands for the first terms. What are those? 4y times 2y. What does that give me? 8y squared. And then O stands for the outside terms. That's 4y and negative 5. What does that give me? Negative 20y. I stands for inside. That's 3 times 2y, 6y. And then L is for the last terms. That's 3 times negative 5, which is negative 15. Okay? And which terms combine? Because they are like terms. Good job, Mary. Thank you. Okay? So that's FOIL for that kind of problem. Those last two we're going to FOIL. They work a little bit differently because number 5 has 2 different variables. When you do the first terms, you get 18. What is p times p? It's not pp. It's not p. P squared. Q squared. Okay. So that's the first terms. The outside terms, what's 3 times negative 11? PQ, right? You just tack it on at the end. The inside terms, what's 5 times 6? 30 PQ. And the last terms, 5 times negative 11? 35. And then the middle terms combine because they're like terms, right? They have the same variables, the same exponents. So what do I get when I do negative 33 plus 30? And then we bring down these other ones. Okay. Who got that one correct? Even though it's a little bit funky. Okay. And then for number 6, the first terms, n cubed, right? N squared times n. The outside terms, the n squared times the negative 1, negative n squared. The inside terms are 4 times n. And the last term's 4 times negative 1. And what combines? Nothing. So it just stays like that. Now on the back of your worksheet, I'm not going to go over that vertical method one. I really do like it, but it just feels like it's just adding more information onto the lesson. Yes, ma'am. Did you have a question? Oh, I thought you were raising your hand. Okay. But we are going to do that last problem with the rectangle. Okay. Does anybody need this up anymore? Krislan, you got it? Yeah. Okay. So talking about this last problem, it says, find the area of the rectangle. Yesterday we did perimeter because we were adding stuff. Today we're doing area because we're multiplying. How do you find the area of a rectangle? What's the formula? Length times width, right? So what is the length here? And then times the width. What's the width? Yeah. So this is what kind of problem? A distributive. So distribute that 2x squared. Hey, what prop? I know I have to be all mathy. What property says it doesn't matter which order you multiply? Commutative, right? Because my order of my commute to work doesn't matter, so the order doesn't matter. But yeah, it is weird to be different. We'll just do this together. 2x squared times x squared. What is that? I'm doing the first. 2x to the 4th. And then distributing to the middle term. 14x cubed. And then the last term. And then what? I need one more piece of information. I need one. Inches. Okay, put your units. All right, so your practice worksheet is due today for a daily grade. It's only, I think, like 8 or something. That is plenty of time. 3:20. Oh, we have more than 10 minutes. We have 13 minutes. You know, human beings can run a mile in 4 minutes. So that means you have like 3 miles worth of math you can do.
Yeah, but math takes longer than running a mile.
That's true.